Hello everyone and welcome back to my Let's Play Minecraft Magically Modded series. Today we're going to work on the computer portion of our tunnel boring machine. But before we do that, there's a few things we need to go over. First off, as you can see here, off camera I've tested this to make sure it runs in every single direction. I've also added the second engine in the rear. Same as the first, except for on these four corners here I have bat boxes. Also, you'll note that this is not connected to a power car. And down here I've temporarily disconnected the rear car from the bundle cable connected to the computer because you don't want both cars running at the same time. This car should only be running when you're going around corners or something like that, which is why it's not connected to a power car, because you shouldn't need that much power. I've also added this chest here for storing discs and stuff. I had to remove that panel right above it to get it to open. And there's one minor problem that I noticed when I was testing this. I actually noticed it earlier. I was going to ignore it, but I changed my mind. You'll note that right here where this orange cable is bends. Because it bends pointing down, it is triggering this deployer when it's active. So what we're going to do is we're going to replace the deployers in these two with some assemblers. So I'll take out these two deployers, go make some assemblers, and be right back. Before I forget, sometime soon I'm going to be building a ruined temple around this obelisk here. If you have any ideas for that, feel free to comment or maybe post a video response or something. I'm not sure what to do it yet, so any ideas are welcome. Yes. We're also going to need to get a couple of bundle cables from our chest down here. Just two of them. And let's make a little room. So now then, we'll put these assemblers above this facing down. And then we can put the orange wire back. And go down here. And break this. Place that with a bundle cable and change this to this method so the bundle cable connects. Then take one of the sonic screwdrivers and put it in the light blue. So the fourth one over. Fill this back up. Put some. That's about the right amount. And we'll repeat that for the other one, and I'll be right back. Now on to the computer stuff. I'm here in the creative world to do a few visual aids. This is going to be a bit more tutorial-y than most of my stuff, but a lot of people have asked for me to explain this, so I'm going to give it my best shot. The first thing I want to discuss is how the computer stores data. Whenever you save a value in the computer, it stores it in what is called a stack. When you save something, you push the value onto the stack, like that. And whenever you recall a value, you pop the value off. Turn that off. note that you get the topmost value from the stack, the last value that you have put in. That's it. Okay. So like that. This makes this a bit counterintuitive. For instance, if you try to type 2 plus 4, the computer would go, add 2 to what? And what the hell am I supposed to do with this 4? What you have to do is push 2 onto the stack, push 4 onto the stack, then add those two values together. This counterintuitive part is what most people have trouble with when they're trying to use this type of computer. But if you're having a lot of trouble, you can write it out on paper and have to be a bit methodical with it. Related to this, there is something you'll see by a lot of fourth commands. You'll see something like this. What this means is it's a notation telling you on this side this is what it expects to be on the stack before the command runs, and on this side is what it expects to be on the stack after, or what is going to be on the stack after the command runs. So for plus, it would be the first number, the second number, then after the command is executed, you would get the sum. I can't prove this. Let's just do it like this. So the first number, the second number, the command, and then the sum. That would be what you would see for the plus symbol. Now note, this is the order they are entered, so that this is actually the top of the stack, I believe. There are a few other commands that help with stack manipulation. There's the period command, which pops the topmost value off the stack and prints it. So if we push one onto the stack and press the period, that will pop it off and print it out, so that now there is no values on the stack. If we push a whole bunch of values on the stack, let's see, 1, 2, 3, the period S command will print all values on the stack without changing the stack. There we go. Next up, we have the drop command. And what the drop command does is pops the topmost value off the stack and throws it away. So drop, and then let's see what's on the stack. The 3 is gone. Okay. The other commands that we have are dupe, swap, over, and right, short for rotate. So the dupe command takes the topmost value of the stack and duplicates it. So what we should expect to see is 1, 2, 2, dupe, and print the stack. Oops. Maybe I messed something up. Let's try this again. Okay, we did mess something up. So we'll push 1 and 2 onto the stack. Make sure those are printed. There we go. And type dupe And let's print them again. There we go. The next command was swap. So let's, crap. Where are the buttons? Get this off. Like that. Let's get rid of this 2. And the swap command takes the 2 values and it will swap the order. So just like that. So what we should expect to see is 2, 1 after we execute swap. There we go. The next command is over, which takes the second value, copies it, and then pushes that onto the top of the stack. So we should see 2, 1, 2 over. There we go. And finally, the rot, short for rotate again, takes the third most value, brings it to the top of the stack, and pushes it on. So like that. So there we go. Just like we wanted. 1, 2, 2. Next thing we're going to discuss is variables. To define a variable, you do it like this. Say delay. We'll define a variable called delay. Oops, maybe oh yeah, it's the other way. Like this. Just to note, I'm a terrible speller, so if I spell something wrong, I don't care. So now then that we defined the variable delay, if we want to put a value in it, we need to store that value. To do that, you type the value. We'll use a delay of 10, so 10, delay, and then store, which is how the exclamation point is pronounced in this. Now then, if you want to push 10 onto the stack, the value in delay, you can just type delay and print that. Actually, that's not right. I messed that up. No, if you want to push the value of delay onto the stack, you use the @ symbol. So this pushes the value of delay onto the stack. There we go. Another way to do that is these 2 commands is the @ symbol and the period, those 2 commands. So if you just wanted to print the value in delay, what you would do is use the question mark symbol. Oh, I should mention the @ symbol is called fetch. So this question mark symbol is called fetch dot. So delay fetch dot. Maybe it's not in this version. Let me see. It may not be. It would appear that fetch dot is not in this version of Forth. That's not a big deal. You'll just have to do it manually. So delay fetch dot like that. And the last command we're going to talk about is constant, at least right now. So what a constant is essentially assigning a name to a number. So let's say something like 77 constant. room temp. So if you wanted to know the room temperature in Fahrenheit, room temp, that pushes 77 onto the stack. So you can use room temp in place of 77, or let's see, that would work too. We will show you how we use constant here in a minute. It's going to be quite a bit useful. And back to variable, why you would want this is, let's say you had a big, long, complicated word, but you didn't quite have the timing right, so you have to keep changing the timing. Instead of constantly doing so, what you would do is use delay in space of a fixed number for the time, and then you could just adjust the value in the variable delay without having to completely redefine the word every single time. I will show you how to do that if I end up using variables when I'm doing this. It makes more sense once you actually get into more practical uses of it. So let's go over to the Let's Play world and get started programming. Okay, now then that we have all this done, we need to take a fourth boot disk made from a blank floppy and a piece of redstone, put it into our disk drive, then start up the computer. There it goes. Okay. Now that that's done, we can take out the fourth disk and get one of these blank floppies. Let's put this in. First thing we're going to do is define a utilities disk. So that's what we're going to name this disk. You can name a disk by typing like this. Disk name, quotation mark, then the name of the disk, is that spelled right? Probably not. Maybe not. But this disk is going to contain things that we would want to use at every single computer, regardless of what else we're going to be doing that. So things not specific to our tunnel boring machine. Now then, a disk has, I believe, 56 blocks. To see what's in a block, you can do the block number and then list. So it's like that. You'll see that each block has 16 lines, and there's a whole bunch of garbage in these lines. To clean that, you can do wipe, which if we did list again, you would see that there is nothing left in here. And if we want to save the changes, we use flush, which actually writes the changes to the disk. Now obviously I don't want to do this for every single block, so we're going to write a word that will automatically clean the disk. While it shouldn't technically be necessary for us to do this, there is a chance with certain codes that some of this garbage that's in the system could be interpreted as a command and mess up a program if it accidentally gets ran. So this is just a additional precaution, and I'm not even sure it's necessary for fourth or not, but I'm going to do it just to be on the safe side. Okay, I've checked, so there are 56. It goes from index 0 to 55 for a total of 56. Now then, to make our thing, we're going to define a new word, and we're going to call it clean disk. And we get this, which is the definition of the word. So we're going to do a loop. So we want to do from 5, 0, do, see, I is the command that takes the counter value of the loop and pushes it onto the stack. So I do, well, there's two values of I on the stack now. Then we want to do, see, block. So that uses up one value. Actually, we don't need to do the do we? Yes. So we can just do block, which will load that block I, so from 0 to 55. Then wipe the block I. And finally, save the changes in the loop with a loop. Whoops, spell the loop right. And a semicolon. I believe that's right, yes. Okay. Now then, let that compile. If we do clean disk and spell it right, what it should do is load every single block and wipe them. So let me give this a little bit to run. Made a slight mistake. This runs until it hits 55, so not actually including 55. So what I need to have done is do from 56 to 0. So I'm going to fix that and then rerun this. To fix it, I need to forget the word. So forget. And now then if I try to use, it doesn't know what it is. So let me redefine the word correctly and I'll be right back. Okay, all the sectors or blocks from the disk are clean. I did misspeak earlier, there is no sector 0. It's from 1 to 55. I think that's right. So we will go check a few random ones. Let's see, 14 list and whatever two numbers I just pressed. 53 list. You can see that those sectors or blocks are clean. Now then, we want to go to the first sector, first block. I keep saying sector, I mean block. And we're going to write some values to the disk. To do that, you need to do the line you want to write to. So 0, starting with PP to write to the disk, capital, and then what you want to write to it. So we're going to write some constants for the wires. If you don't know, the computer uses numbers to refer to the wires based on their metadata. So 2 to the 0 white is 1, 2 to the 2, that's the number after the colon there, or 2 to the 1. Number after the colon is 2. 2 to the 2 is 4, and so on, all the way up to the 15th. So we want to do 1 constant white. And then to save that, type flush so that 1 now looks like this. And for the next value, 1 pp 2 constant orange. And so on and so forth till we get to 15. Since there's only a total of 16, we're not going to put the black here. We're going to put another command. So 15 pp, we're going to tell it to go to the next block. So to load. That's how we do that. And starting on the next block, to list, we will add the black here. So 0 pp, and I'll look up the number for that, and this will be black. So let me type in all these, and I'll be back in a moment. Okay, I've finished typing all that in. You can see here all the colors from white to black, and I've also typed in a couple of commands from the Redpower 2 wiki. I should also mention that all these numbers are on the Redpower 2 wiki too. So the first command from the Redpower wiki is called pulse. I've defined the word pulse. In our nomenclature, the numbers on the stack are the wire number and the delay, then the command, and then nothing's on the stack. So let's see what this does. Over takes the second command on the stack, or the second number on the stack, copies it, and pushes it on the top. So you have wire number is now on the top. Then IOX set will take the wire number from the top of the stack and set all those on. Then the next number of the stack is delay. That'll be popped off, and you'll wait that many ticks. The next command is IOX reset, which will take the wire number and turn off all the wires that you set with IOX set. The next command is patch, which is supposed to be a easier way to edit a word, but I'm not sure if it will work. Running this way, you can always use forget and manually redefine the word. This isn't a great deal better, but it's nice to have if it works. Now then, let's see how to use this utilities disk. What you want to do is type in 1 load. What that's going to do is it's going to run everything in the first block. Then when it reaches this line 15, it's going to run 2 load, which will run everything in the second block. So you only have to type this once, and it will run all this. If you had more, you would continue down here and have 3 load, then on it, so on and so forth. Let's do this. This is going to take a couple of moments to run, so I will be right back once that finishes. Apparently there was a problem with the patch command. It's not a big deal. I'll just do it manually. So what I'm going to do is load that block, and for 4, 5, and 6, I'm going to overwrite those with a blank stuff. So 4 pp, 5 pp, and 6 pp, and then we'll flush that. But you'll notice that our commands the other commands we had, patch, pulse, black, red, are all finished, and we want to forget patch. I'm not sure if this is the right order, so let's try patch, forget. Maybe it's already forgotten. I don't know. Let's see. To list should be fine now. Okay. So now anytime we want to have these commands on any computer, we just take our disk, stick it in that computer, and type in one load. And we have all those utilities. So now we'll start working on the commands just for this machine. Let's say disk name, and we'll call you the tunnel disk. And we want to clean this disk too. It's going to take a moment to run, but while it's doing that, let's go out to here and look at what we have to do. I've made a copy of our portion of the wall that I'm going to be using. You can see on the top over there, for the actual wall, I'm going to be using upside down stairs and upside down half slabs, but being as you can't place those with assemblers, at least not upside down, I'm going to be using cobble so that when I come back with this, I can break it all without it messing up any of the other stuff. So what I need to do is define some rows. There's two ways you do this, I guess I could say. You could have them go in order, for each line. But I'm going to do this with the bundle cable version, which is going to have a color for a specific block. So what's going to happen, you're going to have a color for this line, a color for this line, a color for this line, and then you're going to repeat this color, and a color for this line, this line, and this line, this line, this line, and this line. So you'll have a total of 9 colors used. Let me get out some blocks over here. Just as some placeholders. See, there's the wood. And some of these. So we've used up to lime, I think. Yeah, lime in our machine here. So every value after line is valid. So what we want to do is have this is going to be the first thing is going to be stone bricks for the top one. The first 3 are going to be stone bricks. Stone bricks, stone bricks, stone bricks. Then the next 3 are going to be half slabs, and the next 3 are going to be circle stone. So, circle stone there, and half slabs here. That's for the top row. Then the row below that, the first one is going to be stone bricks. The next one is going to be half slabs. Then the one after that's also going to be half slabs. Then the next one is going to be half slabs, circle stone, and circle stone. So it's going to be half slab, circle stone, then circle stone, stone brick, stone brick. Does that make any sense? I hope so. So like this, this, that, And yes, stone brick, stone brick. Stone one, stone brick. This will be for both sides. So the next one's going to be the middle row, which is going to be, let's see, that, then this, then circle stone. Then the next one should be circle stone, this, and that. And finally we should have this, this, and that. Yes. Oops. Okay, let's see, is that right? Yes, okay. That is correct for that one. And for this, or these I should say, we're going to have the outer rows going to always be dark wood. So is this inner row here? Are the inner rows going to be light wood? A solid line. Then here we're going to have, we need to offset this 2 ahead. So what that means is that when this is pulsing the first row, we need to be placing the pumpkin. So pink's going to be pumpkins, as well as this one and this one. Then all of the others be light colored wood. Now that I just need to mirror, oh crap, this is supposed to be the bottom ones actually. The top ones are all going to be cobblestone. Sorry about that. But just imagine that I put those on the bottom and mirror that for the other half, and you will get them all placed right. So let me do that and I'll be back. Okay, I've got the assemblers all filled up. I should mention that those blocks there are special stone slabs. They have a metadata of 6, whereas normal ones have a metadata of 0. You have to use an older version of Minecraft with the metadata changer to get these, or if you don't want to downgrade, you could use some kind of third-party program, MC Edit or something to get them. I made some in an earlier version of Minecraft and then set it so that I can duplicate these with ThaumCraft at the same price as normal stone slabs. So next thing is to continue with our programming. For this next part, you'll probably want to turn off any chunk letters you have anywhere else in the world, because this is going to create quite a lot of lag, and that will mess up your timing if you have other stuff running. Okay, so we're here. First thing we want to do is set up some manual move commands, starting with, we want to define a variable, so 0 pp variable, and let's call this m delay for movement delay. Then on the next line, we'll go ahead and initialize this variable to say 50. Might be a bit too much, so let's go with 40. That's 2 seconds. No, we'll... Yeah, okay, 40. That should be enough. I haven't had any problems with that. So 40 M delay and store. Now then, the next thing we want to do is actually define the commands. We're going to leave a blank line. Start with 3. Let's do move east-west. Define the word move east-west. Then we want white, because that's the east-west one. 3 pulse in delay. I've determined from tests that 3 is the shortest pulse that you can have to reliably trigger the frame motors. And then we'll do this again. White. 3 pulse in delay. We forgot to do something. We have M delay, and then we need to fetch to get the value from M delay. Then let's do this again. White, 3 pulse, M delay, fetch, and a semicolon. So we will pulse white, wait M delay, and then pulse white again to reset the frame to its original position, the frame motor. And then, crap, we messed up even further. And delay ticks. That's what it should be. We might need to do a loop here. Let's see if we can fit this all on one line. So, ticks. Suppose we could do a dupe to save some space, and then do white 3 pulse ticks. That works. And semicolon. That way we can fit it all in one line. Because we are duping the delay, then white's getting pushed on top of that, 3's getting pushed on that, so everything's going in the correct order. Pulse will pop off 3 and white, leaving only the second delay. Oops, we forgot to put a tick there, didn't we? 3, PP, east west, white, pulse, delay at, dupe, ticks, white, pulse, ticks. And let's see if this actually fits on the line. Okay, yep, just fits. Be sure to note the semicolon, that's important. Next thing we ought to do the move north-south command for PP. Move north-south. It's going to be the same thing except with the orange wire. So orange 3 pulse and delay at dupe ticks orange 3 pulse ticks semicolon. I spell everything right. Okay. Then flush with list. Make sure that fits too. No, that one does not fit. So we'll need to use a loop for that one. So for PP, move north-south, it's 2, 0, do, orange, 3, pulse, M delay, at, ticks. And then loop to end the loop and close the loop. So it will do this twice and that will fit. Next up, we're going to want some commands to change directions. So let's leave another space and define another variable. We're going to call this the deployer or assembler variable, so a delay. Then on the next line, let's initialize this to half a second. 10, a delay, store. Flash list. Make sure everything looks neat. And then we'll start again leaving a space. So on line 9, we'll define a new word, and we'll call this switch east-west. Oops, we messed up. We forgot to do move up and down. Let's do the switch thing then. This will be on line 10 then. Find the word, switch east-west. This is light blue. So we're going to do pretty much the same we did up here with light blue, 3 volts, except for using a delay at dupe ticks. Oops, should use at dupe ticks light blue 3 volts ticks. Pretty much the same thing, except for we have a different delay between, and we're using a different color wire, of course. So let's make sure that fits. Yes. No, that doesn't fit, so we'll have to use a loop. Let me do that, define the move up down command, and reorder these properly. I'll be right back. Okay, I've done that. We have move up and down now, which is using magenta. We have the switch commands, light blue and yellow. And I've added a semicolon and a comment for each of these variables so they say what they do. Now then, we want to move on to the automated moving part, because these are the manual commands. So starting off, we of course need another variable. So 13, let's call this for direction. And we might as well go ahead and initialize it. Variable direction and store it. Okay, then for the last command, we're going to go ahead and load the next block. Whoops. Forgot to do the PP there. Should have stopped then. There's nothing for it to load. Well, here we go. Let's try this again. Let's make sure one list. Okay, go. Team TP to load. And then we'll flush that and go on to the second block. Okay. That must have flushed it from... I hope I have the right disk in there. Yeah, that's the right disk. Okay, I don't know. That must have flushed it from the other one. That's okay, we'll just overwrite it. So, moving on. Okay, the first thing we want to do is define a word for the block breakers. And this is going to be a loop that's going to pulse 10 times. I'm using 10 times because there may be gravel above them, and hopefully that should be enough. And do. So the first thing we're going to do is have a delay. A delay at. Then the color of the block breakers, lime. Then 3 pulse. And actually, let's do this. That's fine. So that would work. Lime, 3 pulse. Then ticks. That's going to give this. Then loop. And close the statement. End the statement. That's right. 10 times. Yes. Should work. Next thing we want to do is have a similar command for the lining, but this is going to be a bit different. Let's use a space here and go on to 2. Going to call this, actually just define what it's going to be. So this lining is going to be wire number dash dash this order, and then we will go ahead and define the actual word. So lining. Let me finish typing this and I'll be right back. Okay, I've made a slight change. I decided to combine the block breaker and the lining command so that start with you add lime to whatever is on the stack, the lining wire number. Then you get to the delay, dupe to the delay. It's actually not what we should do. Delay should be here. Okay, fix that. So 1p. Need to do the lime part. 3 pulse. Then do the delay. And then drop the extra lime plus value that's going to be on top of the stack, which will be the lining wire number plus lime. And let's make sure this fits. Yes, it does. Okay, now then we'll define the move one command. So for pp move one, this is for moving one space. And we're going to take the dupe command, fetch that. Then we're going to do a 3-tick pulse of the direction defined in dupe. See, next thing we want to do is do the block breaker command. So, block breaker. That will serve as the delay between the two as well. Then we'll want to, actually we need a delay here, don't we? Let's do this. Yeah, we'll do this to be M delay. Hopefully that'll work. M delay pulse. Then we can do the block breaker. We'll have to wait and see if that works. M delay may have to be outside of the pulse command. Then we'll do the block breaker command. That'll serve as the delay and another pulse. So dupe. Oops. Already duped something. Oh, we forgot to do something. Actually, I'm going to type this off camera since I'm messing up so much, and I'll be right back. Okay, so I've typed this. Let me explain it. We're taking the direction that's in the direction variable, pushing that onto the stack, the delay that's in the mDelayed variable, pushing that on the stack. Then I'm using a command I haven't gone over yet, to dupe, which duplicates the top two items on the stack, so we're duplicating both these. Pulse will use up one copy of these two. Then rotate will rotate the third item on the stack, which is going to be the lining wire number, to the top of the stack. Run the block breaker command, which will consume the lining wire number from the stack. Then the other pulse command will consume the second copy of these two, and then a slight delay at the end between this command running and the next command, whatever it happens to be. Now the next part's going to be a bit complicated, so we're going to go to the test world to explain something. Okay. We already know about variables, so now we're going to talk about arrays a little bit. You may have noticed earlier when I typed in delay and tried to print that on the stack, I did not get the value that's in delay, I got some other number. What that number is the address of delay. When you define a variable like we did, you get two pieces. You get the actual data portion, so that would be the 10 that we've stored in there, and you also get the actual address of that variable. So that's why you use the @ symbol is the fetch symbol. Another way you can look at it is give me the value at that address. Like that. So, what an array is a whole bunch of these blocks, but they're broken up and referenced by one name. So you define a variable, like we have, and then you tell it to allocate more of these blocks. So you get, we'll say we have a variable that's 3. So if we do variable, just call this delays, then do 2 cells allot, short for allocate. This gives you 2 more than you already would normally get. So you normally get 1. So for this, you'd get a total of 3. That run. So if we did delays, come on, spell properly, we get the address. But it's also allocated the next 2 addresses that can be referenced from delays by just going delays 1, then adding 1 cell to it, and you get the next value. I think that's right. No, that's not right. It's delays 1 cells, then add them together. Then print it. Yeah, there we go. So we're at the next point in memory, which is the address of this next block. If this is delays plus 1 cell. That's the address, and there's going to be the value. So, if we wanted to store something in there, we would go, we could do it normally for the first one. So, delays store. And for the second one, we need to use the next address, which we've already know how to do. So, delays 1 plus 1 cells plus, and then store that in that address. So this whole section here is the address. That's the value we want to store in the address, and this tells it to store it in the address. Let that go. And also we can retrieve that by doing the fetch command as normal. So delays 1 cells plus to get the address, then fetch it and print it out. There we go. So that's the value stored in. And we could do that for the next value in the array by delay cells 2, add 2 cells to it, plus fetch dot, should be nothing or garbage, because there's nothing actually in there. Yes, 0. And we could save a value in that the same way. So you have a contiguous section of memory that you can reference from the name of the first one. that comes in handy for loops and stuff. And that's what we're going to be using for the next portion of this program. So let's go back to the Let's Play world, and hopefully some practical use will help explain this some. Okay, now then that we know how to use arrays, that's what we're going to do. We need to define an array. So, variable, we're going to call this linings. And it's going to contain a total of 15 cells. So, one for the variable and then 14 more. Like this. Because there is 15 cells for, or 15 blocks for each section of wall, segment of wall, I guess you could say. So each one of those will have a entry in this array. Then we're going to define a new word. It's going to be called lining, and it's going to have index dot then address. This. So let's define the word. It is this lining, then cells plus, I think that's right. Let me check this and be right back. Okay, this is how it's supposed to be. It's going to be the address on the stack, the index times cells plus linings. Linings, not lining. Note the S. That will give you the address of that cell in that. And then we need to define each entry in this array. So it'll be something like, let's just do it. So the first cell is going to be pink, 0, lining, store that in it. So this gives the address. This stores this value in that address. So that's what we need to do. We need to do that 15 times. And instead of doing that right here, what I'm going to do is on line 10, we're just going to load the next one. 3 load. And once that gets finishes with 3, it should come back to this one, I think. I need to test that, which we'll do in a short bit. So let me type in all of these commands and I will be right back. Okay, I've got all those done. You can see here, it's the full array. So finally we're going to define one more word. I'm going to call this move15. It's going to be a loop. Then 0, do, then I, which is the loop index, then lining, the value in that address, then move 1, and in the loop. So what it's going to do is take the value stored in the index I, which is going to be from 0 to 14. 0. So that should be 14 there. So I need to fix that. 0 to 14. And push that onto the stack. So pink, gray, so on and so forth. And then run the move 1 command, which will have this lining number pushed onto the stack. So run move 1. Now then let's flush this and fix that one. So 3 block 14. Oops, messed up there. 14 PP. There. Flush that. And let's see about how these look. Let's see. CD trouble. Block breakers there. That's all set. So I think we're ready to test the move 15 command. After we load this into memory by typing 1 load. And we'll see if this loads correctly. If not, I'll have to move the 3 load under the move 15 command. That shouldn't matter. But let's check it and see, and I'll be back once this gets finished loading, assuming it works. Okay, I've got it all working. There were a few typos I had to fix, some slashes and some misspelled delays here and there. But it's all done, so we're going to test out the move 15 command. Just have to type move 15. Seems that our deployers are not working. Our assemblers are not working. Do not know why. Maybe they have the wrong wire color. Let's see. Definitely pulsing. I bet they can't handle 2 colors pulsing at once. I bet that's what it is. So I need to change that. But this episode has taken quite a long time, so I'm afraid we're going to have to wait to next episode to change that. It's a fairly simple change. We just need to decouple the block breakers. This line. Remove this plus. And then we'll fix that. I will... Actually, yes, I'll do that now and then to show you the finished result. Okay, I've separated out the block breaker and the assemblers. The assemblers are now this word. There's a short delay to start with. Then a loop of 3. We dupe the line number. Then a 3 tick pulse. A delay of the assembler delay. And then we loop that. I may need to increase the number of times this loops. Maybe. We'll have to wait and see. But now then, it's time to check this again. We make sure we're moving the right way. No, we're not. So, let's do... Yeah, now we're moving the right way. And then let's try move. block breakers. Okay, there they went. Well, I better get out of here. It's looking good. Looks like we do need to pulse it at least one more time though. I'm going to let it run this segment and be right back. Okay, it's ran through the section, except for the problem with the half slabs, which can be fixed by just increasing the number of times that loops one more time. This seems to work. I'll probably actually do it 2 more times. Obviously the pumpkins didn't get placed because there's nothing underneath to place them on. They have to be placed on top of a block. Other than that, everything looks good. So off camera, I'm going to move this over and start the downward section. And next episode, we'll actually start working on the tunnel. And there's probably 1 or 2 more tweaks I'd want to make. But that's going to be next episode. I hope you've liked this very long episode. Thanks for watching. I'll see you next time. Subscribe if you're not. Like if you like.